In a previous video, we went over this fact that if you want to solve x prime equals ax, where a is a matrix of real numbers, that this has a solution. The general solution of this equation is spanned by the columns of e to the at. Right? Now let's look at the initial condition, the initial value problem. So suppose that we have, so this is the general solution, but suppose that we have initial conditions little x1 of 0 up to, so let's say that that's k1, x2 of 0 is k2, all the way to xn of 0 is kn. In other words, the vector x evaluated at 0 is the column matrix k1 through kn. Well, we know that so the x of t, the general solution to this problem, x prime equals ax, is the span of the columns of e to the at. So one way to write that, so it's c1 times the first column plus c2 times the second column plus c3 times the third column all the way to cn times the nth column. One way to write that is e to the at times the vector c1 to cn. Right? Because e to the at is a n by n matrix, and when you multiply by the vector c1 to cn, you're taking a linear combination of the columns. You're taking c1 times the first column plus c2 times the second column, etc. So that's one way to write the general solution. Now what happens if you evaluate this at 0? Well, you get e to the a times 0 times the vector c1 to cn. Well, a times 0 is just a 0 matrix. And what is e raised to the 0 matrix? Well, the 0 matrix is a diagonal matrix, right? With diagonal entry 0. And we know that e raised to that matrix is just going to be e to the 0t on the diagonal and zeros elsewhere. So you're just going to get ones on the diagonal. So that's the n by n identity matrix times c1 to cn. And alternatively, you could just use the definition of the matrix exponential. So e to the at is the identity plus at plus a squared t squared over 2 factorial, etc. So if you have a times 0, those terms with the t's just become 0, and you're left with the identity matrix. So either way, you get the n by n identity matrix times c1 to cn, so that's obviously just the vector c1 to cn. But we're given that x of 0 is the vector k1 to kn. So what that tells you is that your initial, the ci's, the constants that will satisfy the initial value condition is just k1 to kn. So what that means is, the conclusion is, that if you have an initial value problem, x prime equals ax, and x of 0 is the vector k1 to kn, the solution is just e to the at, that matrix, times the vector k1 to kn. Okay. Okay, so that's one thing I want to say about initial value problems. And I guess that's it for this video. So in another video, I'll do an example with diagonalizable matrices.